Have you ever thought about how things move? What causes objects to go from one place to another? How can we tell when something is in motion? In this video, we'll explore the basics of motion to gain a better understanding of these questions. We will try to look at how things move and why they move. When an object moves, it does any of these four basic motions: random, translational, rotation, or vibratory. In random motion, objects move disorderly, bumping into one another. When an object moves in space without rotating, it is undergoing translational motion. Rotational motion is when all points on an object rotates in concentric circle. Vibratory, or oscillatory, or periodic motion involves the to and fro movement of an object. The only reason why we can perceive motion is because of something called relative motion. We must compare movement of one object to another for us to perceive motion. This other object is called the frame of reference. The background of this clip is currently moving, but it is not noticeable because there is no frame of reference to compare motion with the background. Now let's add some object to the background. We can now perceive movement because of the relative motion between the background and the circle object. The circle object acts as a frame of reference that creates the relative motion. It is the same thing that happens when you sit in a moving vehicle. Looking down at the vehicle without looking through the windows, it feels like the bus is not moving. This is because you and the vehicle are moving at the same speed, so there is no relative motion between you and the vehicle. But when you look out the window, you are able to feel the movement of the vehicle, because you can now compare your movement to objects around that appear to move in the opposite direction of the vehicle. Without frame of reference, it will also be impossible to get the position and distance of an object. For example, to locate the red dot on the screen, we must first provide a point of reference. To do this, we draw two lines intersecting at point O and perpendicular to each other. The horizontal line is the x-axis, also called abscissa, and the vertical line is called the y-axis, or ordinate. Values to the right of O are positive, while those to the left are negative. Values below point O are negative, while values above point O are positive. To get the position of the red dot, we draw a line from the center of the dot to the x and y axis. The values of this point together is called the coordinate of the red dot, and this gives us the position of the dot. To know the exact position of an object, we also need its distance and direction. If we just say an object moves 50 meters from point O, it is not clear where the object will end up. The object could be any point that is 50 meters from O. But by specifying the direction, we are able to locate the exact point the object ends up at. So if we say 50 meters to the east, then we are certain that the object ends up at point A. The shortest distance from an object and its frame of reference is called displacement. Now note, displacement is not the same as distance. If a vehicle moves 20 meters to the west, then moves another 30 meters to the north, the distance it covers is 50 meters, but the displacement is just 36 meters. Even though the vehicle has traveled a longer distance, it has only been displaced 36 meters from point O. Let's look at other basic concepts of motion: speed, velocity, and acceleration. Speed and velocity. These terms are usually used to describe how fast an object is moving. To know this, we compare the time it takes the object to cover a particular distance. When we divide the total distance covered by the time it takes to cover the distance, we get the speed used by the object. If a boy walks a distance of 50 kilometers in 2 hours, then the speed of the boy is 50 divided by 2. This gives us 25 kilometers per hour. If an object covers the same distances, in the same amount of time, we say the object is moving with uniform speed. It is also very important to note that speed and velocity are not the same. Speed does not require direction, but in discussing velocity you must provide the direction. Velocity is related to displacement. When we divide the total displacement of an object by time, we get the velocity of the object. When equal displacement occur in equal time interval, we get uniform velocity. For example, if a vehicle is displaced 2 kilometers every 2 seconds, we say the vehicle is moving with uniform velocity. An object moving in circular path can have uniform speed, but not uniform velocity, because its position is always changing. Acceleration describes how fast an object changes position. It is the rate of change of velocity with time. If the change results in a decrease in velocity, it is called retardation or deceleration. If a vehicle changes velocity from 20 meters per second to 30 meters per second in 5 seconds, we can calculate the acceleration using the following formula. V represents final velocity, which is 30 in our case. U represents initial velocity, which is 20 in our case. T is the time, which is 5 seconds in our case. When we apply this formula, we get 2 meters per second square as the acceleration. I will be making more motion videos in the future on topics like velocity time graph, circular motion and friction. So if you like this video, please subscribe for more. For now, bye.